Assalamu alaikum wa rahmatullahi wa barakatuh. Hello everyone. Welcome to lecture 14, Organic Chemistry 1, Structure and Stereochemistry of Alkane and Alkenes. Today we will talk about the conformation of monosubstituted cycloalkane and start with the methyl cyclohexane. Methyl cyclohexane, where the methyl is axial, and we would like to draw Newman projection. We will look at the molecule from this carbon and that carbon, okay, and we'll end up with methyl on the carbon, hydrogen, CH2, and then this carbon will have two H's, and in the back HH, CH2, H, H. Okay, as we mentioned before, that the cyclohexane has what we call it ring flip. So if this one will flip, will give us that one, and axial methyl will be equatorial. Okay, and if we look for the molecule from this side, these two carbon here and that, okay, and start drawing Newman projection, we will come up with, okay, CH3 here, and see that it's 2 in the back, it's anti, okay, and this is more stable, of course, than this one, which we have here bush-like structure. The metal in the axial form, okay, conformer, we can see that the methyl group has 1, 2, 3, and 1, 2, 3, what we call 1,3 diaxial interaction or van der Waal repulsion. Remember that we talked about van der Waal radii، حاجة احنا بنتخيلها لحجم الجزيء في الفراغ، فهنا هيكون في repulsion force. The energy or enthalpy between axial and equatorial conformation is 7.4 kilojoule per mole. Because there are two 1,3 diaxial interaction in the methyl cyclohexane, each interaction represents 1/2 of this, will be 3.7 kilomole. Repulsion between this and that is 3.7, this and that is 3.7, make a total of 7.4. Here the table shows you some other substituent like chlorine, it's 2, OH 4.2, here is methyl 7.4, ethyl 8, isopropyl 9.2, tertiary butyl 22.8. To show you the 1,3 diaxial interaction or van der Waal repulsion, I choose the 1,3 dimethyl cyclohexane trans, where one of the methyl should be in equatorial and the other will be in axial. If I draw the mono and ask the program to draw the 3D, we will immediately transfer it to the more stable conformer, so I will not be able to see the 1,3 diaxial. That's why I selected this molecule where I force one of the metal to be axial. Let's look at this one. Here is hydrogen, and this is hydrogen, H, H, H. This is a methyl group. Okay, as you can see now, there is 1,3 diaxial, 1,3 diaxial, two of them. Let's see it in here. See, this is hydrogen, and this another hydrogen, and this is the carbon CH3. How they are really close to each other in this what we call space filling model. Okay, they are not far away as we draw it in this structure. They are very close to each other. That's why there is a repulsion. Disubstituted cycloalkane. Let's look at the molecule where CH3 here is down and Cl is up. If you would like to draw it in the chair form, this is the chair form. Okay, one of them, Cl is up, so it is axial. CH3 is down, so it is axial. Flip, then this one will be up and this will be down, but in equatorial positions. This is equatorial and that is equatorial. Of course, this one will be more stable and the equilibrium will be shifting to this one, to that conformer. Okay, and this is higher in energy than that one by, of course, we have CH3 diaxial 7.4, and we have chlorine diaxial 1,3 diaxial, which is 2, total of 9.4 kilojoule. Let's apply it to this molecule. We have CH3 up and CH3 is down, CH2, CH3 up, so it will be in that chair form, up axial, down will be equatorial, and we will have ethyl 1,3 diaxial. Looking back to the table, you will find it 8 kilojoule. If we make the flip, this will be equatorial and this will be axial. Here we will find CH3 1,3 diaxial, which is equal to 7.4. Of course, this one is lower in energy, so again the contribution or the existence of this conformer will be higher than this one. Trisubstituted cycloalkane. CH2, CH3 is up, CH3 is up, Cl down. So up means axial, up means equatorial, down means equatorial. Okay? Flip, this will be up means equatorial, this is up means axial, This is down means equatorial, axial. Okay, so in this conformer we have CH3 1,3 diaxial with 2 hydrogens, and Cl here is axial. There is 1,3 diaxial between Cl and 2 hydrogens. From the table, that's methyl 7.4, Cl2, total of 9.4. Here we will have only the ethyl. Axial ethyl is 8, so this one will be lower in energy and contributes more to the conformers in this for this compound. By the way, they are one compound, but that one compound is in different conformers. Okay, this is so far what we talked about is one or single compound in different conformers. Okay, draw the least stable chair conformation for the compound below using the data in the table to calculate the total strain. That's methyl up, chlorine up, methyl up. So if we start the chair, this one, methyl up, chlorine up, axial, methyl up, axial. Flip will be equatorial, equatorial, equatorial. Definitely this is more stable. So this is less stable. Methyl and chlorine, methyl and chlorine, 1,3 diaxial, so we have 2 methyl chlorine, 2 times 16.7, 33.4, and we have methyl methyl. We have methyl methyl 1, it's 15.4, total is 48.8 kilojoule per mole. So this is the less stable, and approximate difference in energy between them is 48.8. Draw the more stable chair conformation for each of the following. هنا عندي methyl group down and tertiary butyl down. Drawing chair, the down will be equatorial, and 1, 2, 3, okay, 4 from each other. That will be down will be the axial. If we flip it, this will be axial and this will be equatorial. The repulsion here is the metal is axial, so it is axial metal, 7.4. Here is the axial tertiary butyl, that's 22.8. So this one is less stable, and the more stable will be the tertiary butyl group in the equatorial position. Let's see that one. The methyl group here is down, the chloro is down, the chloro is up. Again, this is down, so it's equatorial, this is axial, and this is axial. If we flip it down, this methyl will be axial and the chlorine will be equatorial. In this one, we have the methyl axial, so we have methyl axial 7.4. Here we have two chlorine, okay, 1,3-diaxial. This one with these two hydrogens. So that's 2. And this Cl with these two hydrogens, and that's another 2. So it's 2 times 2 is 4 kilojoule. Still, this is 4 and that's 4.7. So which one is more stable? This one will be more stable. Determine the relative energies of the two chair conformation of one trans 1,2-dimethylcyclohexane. Which conformation is more stable? We will come to this later transiences. When the methyl group, one is down and one is up, we call that trans. So this is down and this is up. So both of them are equatorial. When we flip it, will be axial axial. In this structure, we will have methyl axial and methyl axial 1,3-diaxial to 2 times 7.4, make it 14.8. Drawing the Newman projection, you will see that these two methyls, CH3 and CCH3, are in gauche position, and the gauche interaction, we took that before, is 3.8. So in the in this form, we have the gauche, but in this one we have 2 1,3-diaxial for the methyl group. The difference will be 14.8 minus 3.8, that is 11 kilojoule, approximate 11 kilojoule per mole between these two conformers. A compound A exists predominantly in a chair conformation, while compound B exists predominantly in the twist boat conformation. Explain. Molecule A, the tertiary butyl group is down, and tertiary butyl group here is up. So it could be, if that's chair form, down here will be axial, and this is axial. But this molecule will flip to more stable conformer, where the two tertiary butyl group will be in equatorial positions. Okay? So that's a stable, no torsion strain. For compound D, up will be axial and up will be equatorial. So in this conformer, we have torsion strain, or 1,3-diaxial of tertiary butyl group with these two hydrogens, which is around 22.8 kilocalorie per mole. Okay, so if we flip this conformer to the other chair, again we will have one equatorial and one is axial. However, if we make it in the twisted boat form, we can put these two in equatorial positions. They are far away from each other, okay? And here the molecule will be more stable in that conformer. See you in the coming lecture. Bye bye.